All right, grade 10. So in this short little video, we're going to try to add a layer of challenge to the work calculations we just did. So I alluded to this, but if this guy is lifting a weight, but not at a constant velocity with acceleration, how would I go about calculating how much work he's going to do if he also has acceleration? Okay, so in this case, the applied force that he's putting up, so I'm going to have a free body diagram, the applied force must be greater than the force of gravity. Whoops. Okay, so his applied force is greater than the force of gravity. Therefore, the net force does not equal to 0. Okay, so work is going to be equal to the applied force that he's putting on to this object, how much effort, how much applied force he's putting up, times the distance that he lifts that object. So how would we go about calculating the applied force if he's going to accelerate that weight upwards over 2 meters? Okay, now let's give a number to his acceleration. Let's say that he accelerates at 2 meters per second squared. So there's an overall acceleration of 2 meters per second squared in the upward direction. How would I go about calculating the total force that he's going to apply? Okay, so what I need to understand is that if F net, the net force that he's applying, is not equal to 0, then there will be acceleration. And I remember that that F net is equal to ma. So if it's unbalanced, if there's an unbalanced force, there's going to be acceleration. This is Newton's second law. If I know the mass of the weight times that acceleration, that's equal to net, the net force. And that net force is the difference between the applied force that he's putting on minus the force of gravity is going to be equal to mass times acceleration. That's an important relationship that we developed. So if I wanted to find the applied force that he's going to be putting on, I can move the force of gravity over to the right-hand side of this equation. So the applied force is going to be equal to mass times acceleration plus the force of gravity of that object. So the applied force that he puts on is equal to 50 kilograms times 2 meters per second squared. That's what we said was the acceleration that he's pushing up with, plus the total mass times gravity. So 50 kilograms times 9.81. Sorry, those are really small numbers there. Okay, so what is that going to be? I'm just going to round this to 10. So 500 newtons plus 100 newtons. The applied force that he is pushing is around 600 newtons worth of force. Okay, so then to calculate the work is equal to 600 newtons times 2 meters, which would be 1,200 joules. Okay, that was a lot more than the work that he put in the first time without acceleration. So that's important because soon you guys are going to be trying to calculate the work you do in an exercise, and this relationship will become really, really important. Okay, so let's look at a much harder situation. What about doing work when I'm pushing a car up a hill? Like soon you guys are going to be driving cars, you're going to run out of fuel, and then you got to push your car up Abalempe, okay, or up Achimota. All right, so I'm going to draw a situation here, okay, and we got our car, and we got somebody in the class pushing that car up that hill. Now, let's imagine that the person starts at the bottom of the hill and pushes the car all the way to the top, and the vertical incline is going to be 20 meters. All right, and the angle of the incline, again, is 30 degrees. Okay, so how would I go about calculating the work that this person has to do to push that car all the way up to the top of the hill? Okay, and to make matters worse, there's friction. Okay, so there's a friction coefficient. Actually, I'll save that for grade 11. There's no friction. Okay, or better yet, there is friction, but I'm not going to make you calculate it. I'll just say the force of friction is constant and is 550 newtons, or 500 newtons. Let's say it's 500 newtons. Oh, okay, sorry. Okay, so this person is going to apply a force, and when they're applying a force, they have to apply a force such that they can lift the object uphill and they can work against friction. How are we going to solve this? Okay, so the total work that person's going to have to do is equal to work against gravity plus work against friction. Okay, so that's the way I'm going to look at this. Now in grade 11, you're going to find a much simpler way of looking at it. But right now I'm just going to look at two things. When I'm pushing that car up, I'm lifting it 20 meters high, and I'm also working against friction across that entire distance. So how are we going to solve that? Well, the work against gravity is not going to be difficult. Let's say that this car is 1,000 kilograms. So the work against gravity is going to be the force of gravity times the distance. Let's imagine this person's pushing that at a constant velocity, so the net force is 0. So the force that he's applying to lift it at a constant velocity is going to be the force of gravity times the distance, that vertical height. Okay? Another way of writing this would be mgh, the vertical height. G is the acceleration of gravity, and m is the mass of that car. Okay? And then the work against friction is going to be the force of friction times the distance. Okay, and that distance is this distance over here. Okay, so already I can see a little bit what I'm going to have to do. So as I'm going to continue, I'm going to plug numbers in. So 1,000 kilograms times 9.81 times 20 meters plus, now here the force of friction we said was 500 newtons. They gave that to me in the problem. Times the distance. Now, how do I calculate that distance of this triangle? It's a right triangle. This is opposite, this is adjacent, this is my hypotenuse. How am I going to calculate that distance? Well, opposite, hypotenuse, that's a sine relationship. Okay, so I remember sine theta is equal to opposite over hypotenuse. Okay, so if I want to solve for the hypotenuse, okay, my hypotenuse is equal to opposite over sine theta. All right, so in that case, the distance is going to be equal to 20 meters divided by sine of 30 degrees. And then this becomes 1,000 kilograms times 9.81 times 20 meters plus 500 newtons times 40 meters. Okay, and now let's punch this into our calculators. Okay, this is 19.6200, and this is going to be 20,000. Okay, if you add that together, that gives you 216,200 joules. Okay, that's a lot. It's a lot of work. 216.2 kilojoules, okay, to lift that object up that certain ramp, that height. Okay, so you can pause this video, go back, write down this procedure, and try to understand how to calculate it. And that's about as difficult of problems I'm going to make for you guys when I'm asking you to calculate work. So again, very soon you're going to have a Criterion D assessment where you're applying your knowledge of work to real life in motion. And these are some calculations where I can calculate the effort, the amount of work that I have to put into moving objects.